everyone, and welcome to Duodecimal Division. My name is Eric Larson, and this is the 7th video in a series of videos that I've called The Secrets of the Numerals. The reason I'm calling it that is that I'm revealing to you all the hidden geometric information that's encoded within all of the numerals when they're applied to this diagram. Or more clearly, actually, somebody used this diagram to generate all of the various numerals using the relationship between this series of circles that you see and the Cartesian plane beneath. So what we're going to do in this video is look at the numeral that represents the number 7 and see why it has this particular shape. And we're going to put to rest once and for all the argument, if there is any kind of argument or discussion about whether the number 7 or the numeral that represents the number 7 is supposed to have that little line across the middle of it. So you can look forward to finding that out in this video. So what we're going to do is go to the 7th circle in the series, the circle with the square root of 7 radius. And first of all, just see where it sits on the grid. So again, this numeral is, or this circle is like the 6 and the 3, or the square root of 3 and the square root of 6. The square root of 7 doesn't actually intersect any lattice points. It's also a circle that's floating between all the lattice points. So what we're going to do is first just use this original geometric pattern to find an exact point for the 7, and then we'll work off of a lattice point close to that point. So we're going to go to the square root 3 radius circle again, 1, 2, 3, this point right here, and then we're going to go straight up. Actually, basically we can go straight up because we're going to be making these other points here on this square root of 4 radius circle, and down here also just a nice straight line, and draw a line going straight up, and we're going to go up the length of 2 to where this line crosses the line that has the y coordinate of 2. So this point right there. So that's the point that defines the square root of 7 radius circle. So what we're going to do is go to the lattice point that's really close to that, and that'll be the point that has the x coordinate of, again, 1.9 and the y coordinate of 2. So now what we're going to do is we're going to flip the board, because for this particular numeral we're using the lines that are generated from the geometric pattern that's called the dodecagon, or that it is a dodecagon, and that's also one of the foundational geometric shapes that we're using in these numerals. It's one that I've introduced to you in the first video, and we used it also for the number 3, or the numeral that represents the number 3. Now we're going to use it also for the 7. Mostly, if you can think about it, or if you remember, the slope of that line, or the lines in there, had the 0.7 in there. You're going over 1 or up 1 and 0.7. So that's the line that they chose to use to help build this particular numeral. So I'm going to flip the board around where I have that geometric pattern on the back, and then we'll take a look and see if we can figure out why the 7, or the numeral that represents the number 7, looks the way that it does. Okay, so I flipped the board around, but what I realized I need to do is also flip it around top to bottom, because this numeral actually goes longer this way. So I'm going to erase these, this marking here, and just change it so that it's higher up. So again, we're going to go 1, 2, 3, 4, 5, 6, 7, and this point right here, it had the x coordinate of 1.9 and the y of 2. Okay, so maybe we should just first figure out where exactly that's sitting on the grid, how close it is to the square root of 7 circle. So I think I'll write it down here. I'll just, we know we've done this. We've used the 1.9 a lot, actually, because we're always working off the square root of 3 and then just going out a little bit. So 1.9 squared is 3.09, and of course 2 squared equals 4. So 4 plus 3, basically the answer, that's 7.09. So that's the square root of 7.09. So that's where that point is sitting in relation to the square root of 7 circle. So now what we're going to do is draw a line just along here to the other side where the circle touches down on that line, just right there. So we'll just draw that, all these funny sounds. So this is negative 1.9 and 2. Those are the coordinates of this point right here. So what's interesting about that line then, it is the length, you see that up here, yep, of 3.6. So it goes 1.9 in one direction, 1.9 in the other. 2 times 1.9 is 3.6 in base 12. So now what I'm going to do is draw a line at an angle. You know what the numeral 7 looks like. Going down, basically we're going to parallel this line here. Again, that has the slope of, now we're going to be going to down 1 and over 0.7. And actually what I'm going to do is just slide the board over here to make it easy for me. And I'll just trace it like this. I'll kind of go like this way. Here we go. So 1, 2, 3, 4, 5, 6, 7. So there we go. That symbol is the height of 7. So I'm going to put it back here just like that. When we do that, we can see that it's crossing this point right here. So I'm going to make a point right there just to demarcate that, because what's so important about that point? Well, I'm going to go and get my compass and show you something. All right, got my compass. So what I'm going to do is put it on this point here, put the point there, and we've got it so it's sitting on that straight line just there. Now when I swing it down, we see, look, it's touching down right on that point there. So, and this is the length of 3.6. So 3.6 and 3.6 is the length of 7. So you can see that these two lines added together is the length of 7. So again, similar to the 6, how we had a line that was very close to the length of the value of 6. Now we have a length that is the length of 7 incorporated in the symbol, even though the square root radius 7 circle isn't actually landing on any lattice points. We're still able to have lines that are sitting on lattice points that define the size or the length of that number. And what's interesting about that particular point there, you can see these other lines going down that also has the length of, or the slope of going down and over 0.7. I can make a point there and point there. So each of those points is the length of decimal 7 or 0.7 from there. Again, those are both defined by those slopes. So if I join those 2 points like that, now I'm making a demarcating line to divide that part of the symbol and this part, and both of those lines have the length of 0.7. So we've got 2 times 0.7. So again, the decimal version of the numeral or the number is incorporated within the design. So that's why that line is there. So again, I just start writing down all these different lengths. We have the height of 7 incorporated, from here to there is 7. And we have the decimal version of 7 also. And then we have this 2 times 3.6. 2 times 3.6, which also, of course, results in 7. So that's why the numeral 7 looks the way that it does. I'll just write the coordinate points here of this point. It's the y is going to be 1, 2, 3, 4, negative 5. And the x is 1, 2 point, or negative 2.4. Right, it goes 7, 12, 9, maybe 10, yeah, 2 minus 2.4. And then these points here, on this side, the x is 0.7, and the y is negative 1. And on this side, it's negative 0.7 and negative 1. So that's the points on either side. Got these ones here, those ones there. So again, just to be clear, when this line swings down, it's just past here a little bit. Remember, this is going to be a line that's going to be it's a square root kind of thing. Well, we can actually maybe do that just to be clear. We have the length of 3 on this side, so I'll draw this triangle here. Again, it's a right angle triangle. This side is 3. This side is 1.9. So again, 1.9 squared, I'm going to say it equals 1.9 is the square root of 3.09. Square, 3 squared is 9, so I'm adding 9 to this. 9, so AB 10, so that becomes the square root of 10.09. So that's the length of this here, 10.09. So 3.6 squared, 3.6 squared is 10.3. I'm slowly getting my multiplication times in base 12 figured out. Okay, 3.6 squared is 10.3, and so that 3.6 is the square root of 10.3, and so this is the square root of 10.9. So we know that this, as that swings down, it's just coming a little bit past there in the name of precision. I want you to know how that works out. But again, like the 6, that line wasn't exactly 6, but just a little bit longer. This one also isn't exactly 7, but just a little bit longer. But again, 7, 7.7. I'll put the whiteboard behind so you can see all that more clearly. Coordinate points for that line in the center, coordinate points. Okay, so that's why the numeral 7 has the distinctive shape that it does. So hope you enjoyed that. And now we're going to go to the next video in the series, the one for the numeral that represents the number 8. And we'll see why that particular numeral has its distinctive shape. So I hope you can join me for that. Thanks for watching.